Is that all right? Do we have a good lunch? I feel really sleepy already. So you've all signed in to PFAS discussion, yeah? Who can say the real name PFAS properly? Come on, other than you lot. Can anyone say it? No? Oh, okay. Well, by the end, you should be able to. All right, so we've got 3 presenters who are really, really highly qualified and capable and know shit about PFAS that we're going to work through. And we're going to do presentations, but we're actually, because it's more interactive, workshop-y type, if you put your hand up, I'm very happy to break and have a chat, right? I'm not going to use mics because I think it's small enough that we don't need it, okay? But if it's not working out and you can't hear, can someone just let us know, right? And we'll go get the mics, right? But it's kind of intimate, right? Yeah? Just don't come too close. All right. So to set the scene, we're going to have David Springer from EnviroLab. Oh, you're doing all the driving. Okay. Can you go to... Oh, no. Did I do that or did you do that? Okay. We're going to start with David Springer, who's going to set the scene of where you can find this stuff. And then we're going to have a bit of a deep dive into how it goes through the waste sector. And Charmaine, I've just realised I spelled your name incorrectly, is going to follow up with some of the treatment options. But we want to have a discussion in this session, right? You're not just sitting here and taking. We want to have a chat, all right? Over to you, David. And I'm going to try and get Olivia Rodriguez tickets because I'm sitting on pre-sale. I've got flashbacks to Taylor. And so if I scream, you know I've got it. All right?
And also, Hoodoo Gurus just went on sale too, if you're interested in that too. Okay, thanks everyone. So I'm going to sort of set the scene just to start things off for us all. So, and as Gayle said, just interrupt at any time. So PFAS, there are estimates that there are between 5,000 and 15,000 PFAS chemicals out there. And you'll see the little family tree at the side. You've got PFAS as the overarching group, and then the chemicals coming off it. The 3 that regulators are looking for most are PFOS, PFOA, and the PFHXS. They're the chemicals that have the most data on it, most health data. So out of those 5 to 15,000. Labs only actually test 28 of them. So we are testing bugger all PFAS. Very persistent, long range dispersion, so they are everywhere, they're ubiquitous. They're all man-made chemicals. PFOS and PFOA are still manufactured overseas. I think we all know what countries are the general culprits in doing things like that, so they are the countries still manufacturing them. Something that people don't know is that they are getting imported into the country every day, and of course it's in all of our bloods. So these are the good old days. I've done a lot of talks to fire brigades. All of these things, the old fireys said, yes, that happened, including that one in the middle where there were budget cuts back in the 1980s, and they weren't allowed to buy dishwashing liquid, so they just used firefighting foam to wash their dishes in. They would all nick it a little bit for their kids' slip and slide at Christmas and all that good fun stuff. So I wanted to show you where it's coming into the country in everyday goods. So these are all samples that we've tested in my lab. So, and I've only put up the PFOS and the PFOA, not the other 26 compounds. So the eye pencil, you might see 40 parts per billion of PFOA, but the total PFAS, that's the total of the 28, was actually 480. So that makeup, 160. The plumber's tape was really interesting. We actually soaked that in water for 3 days and then tested that water. And we found 400 ppb coming out of there. So that's not out of the realms of possibility that you go away for the weekend, and if you take your first flush drink out of your kitchen tap and you've got a big piece of plumber's tape hanging in there, that could well have leached out of there. The dishwashing tablet, not much, and the fryer pan, we really had to go to town to scratch up that to actually get that to come off. So something you might not have heard about is the TOPA analysis. So as I mentioned, labs typically do 28 compounds. My lab will go up to 40 compounds on request, but there are no guidelines for those things and no one wants to pay the extra money, so we very rarely do the 40 list. So TOPA is where we are oxidising the sample to pull out all of the hidden PFAS in the sample, and we can then report that hidden PFAS as one of the 28 PFAS that we're actually analysing for. So it's looking for the hidden PFAS in products. And what we do, we oxidise the sample at 85 degrees for about 6 hours to pull that out. So I'm just going to show you on those same cosmetic slides. So we've got, if you just look at PFOA, the fourth one up from the bottom, in the makeup, we found 20 parts per billion just doing a PFAS. But once we toperized it, we're pulling out 700 ppb of PFOA. And the same in the eye pencil as well, that got up to 600 ppb. So it's quite a lot in there when we're actually looking at that. Oh.
So I'm going to ask you a question.
Oh, hang on, that's gone right to the very end.
Oh, is it? Oh, that wasn't what we're supposed to do.
No.
Go back. Oh, it says it's only 9. Okay.
Oh.
So Queenslanders, Christine, we know about TOPA because Desi just brought in their, and my head exploded when you said you went through TOPA and got to 600 parts per billion. So now under the Queensland testing and treatment for PFAS, TOPA is one of the 2 tests we have to do.
Yes.
And they've also said 3 parts per billion. And you said the plumber's tape was after soaking 2 days. How many?
That was, what was that, 400.
So we have to make organic output compost at 3 parts per billion in Queensland. Do you think we can do that?
No, I don't.
Oh, but they keep telling us we can. So
No.
how does that work?
Exactly. Impossible. Unless someone knows.
Oh, plumber's tape. That's the problem. Just get the plumber's tape out of the compost.
Exactly. And then everyone will be fine.
Oh, okay. So you mean Desi might have that wrong?
Well, they think they've got it right, but it's not going to happen. I can't see that happening. And I've got some further evidence to show you soon.
Okay, I'll go sit down again.
So, just look at this. This I couldn't read, and fair enough, it was on an eye pencil. There's not much room to print, but I do have a bit of a problem with labelling as well. So what you're looking for the F chemical, and this one I literally had to use a magnifying glass to find that F chemical. My glasses couldn't even get down that low. So where does all this makeup end up? Well, it's all washed off in the shower, I assume, and is all ending up in biosolids. So biosolids are a very, very important resource for Australia. Our poor soil, we should be using biosolids more. And virtually every biosolid sample we test for, we find PFAS in it. This is just a random sample. This could have been from a local council, sewage works. I don't know, I just chose a random sample that we did. And you'll see there, probably the bottom one, let's just go for the total PFAS. So 95 parts per billion in that biosolid sample. Once we applied the TOPA technique to it, we're pulling out 250 parts per billion. So biosolids, which should then be spread onto farmland and forestry, is a little bit of a problem. Yes. So another really good example, this is an organic poultry manure compost, which is currently on the market. It just looked like, you'd buy this, it looked like chicken manure, a few feathers in there, things like that. I just took the average of about 5 samples we did. They ranged from between 20 and 80 ppb. So back to you, Gayle, the Queensland guideline is 2 ppb for this compost. So this is currently on the market. You can go out and buy this. Now, I'm no regulator. I don't know what this company did with our results. I would assume they probably just filed them away and sold their product. Who knows? So I just want to mention, you would have been greenwashed out at this conference, but I just do want to mention greenwashing as well. And you'll see I've got a little prop on everyone's table. That is what I'm going to talk about. These sugarcane compostable, well, not really compostable, takeaway plates. So if you have a look at this biocane, and if you read that, eco-friendly alternative to plastic, plant fibres, rapidly renewable plant fibres, no added PFAS, make a positive change. The lovely logo with the nice green leaf in it and the nice circular thing. Very confusing website. So again, lots of words about renewable. Now I came about this because at Christmas I had a lot of people over and we didn't want to wash up, so I bought a whole lot of sugarcane mulch plates. And obviously there's no detail on these plates. You have to actually go into the website to look at all this. And I'm no rocket science, but I bought them thinking, oh, sugarcane, that's really good. And I just chucked them all in my compost bin. So you'll see there the raw material, plant fibre with PFAS. It's actually on their website saying they add PFAS to it. Manufactured in China, of course. And here I was thinking that I'm helping sugarcane farmers by buying their excess mulch. Industrially compostable, no. Recyclable, no. Home compostable, no. But it did all go into my compost heap. This company does have plates with no added PFAS in there as well. But again, you've got to go to the website, and it's very hard for the average punter to work out what is happening there. And again, you'll see that with the no PFAS plates, it actually says home compostable pending certification, but industrially compostable, no. I was at a conference and I hijacked the conference with one of these plates. The conference was at a university and all universities use these sugarcane plates. And after lunch, I went and looked through the garbage bins. Now, this was an environmental conference. There would have been about 100 environmental consultants there. And I did a quick survey and said, who has composted their plate from lunch? And half the arms went up in the room. So 50% of professional environmental scientists would compost these, which made me feel better for composting mine. So this plate on your table, this is the actual plate. And you'll see there's a coating in there. So that coating is to stop any of the liquids. You know, if you buy a wet curry or something, you don't want it coming out. So it's coated with PFAS. And that actual plate, I had to buy 1,000 of them. So I've got plenty if anyone wants them. These are the actual results of that plate. So again, we did a PFAS on them, found a bit of PFAS when we do it, but once we applied the TOPA technique, that's when we pulled out all the PFAS. So 50 parts per million, just in that one plate.
So how do I get a ton of PFAS, a ton of FOGO, sorry, not to have 3 parts?
Exactly. Impossible.
Christine?
Well, you don't put that in at all plumber's tape. We're sending the list.
Yes. Exactly. So I'm almost finished. I have a uni student at work who is doing a little composting experiment. So she's got a couple of compost bins up on our veranda at work. She's taken these actual plates. She's thrown half in full and she's ripped up the other half. So after 7 weeks, you'll see they have started to break down actually a little bit. But up to, well, just before this conference, she was up to week 7. So we quickly did some testing on it. So this is the ripped up plate she did. Now she's doing an interesting thing. She's composting normally, like all of us would do. And she's also, in the other half of the compost bin, she's treating it. So in this case, she's spraying on 100 mils of potassium persulfate. We use that because that's our agent that we use in the TOPA test. And it's not out of the question that an industrial composting system will have other chemicals in there that could be contributing to the TOPA. And in industrial composting, I'm sure things are getting up to 85 degrees as well. So it's not out of the question that in your compost bin, you can be doing a natural TOPA in there. So if you have a look at the results, so the untreated, doing nothing, After 7 weeks, we're finding 8 ppb in the compost. When we do a TOPA, 49. But on the treated one, where she's been spraying the chemical on, and this is just 100 mils once a week, we're getting up to 200 ppb TOPA PFAS coming out. She took it a little bit further then, and she did some mushrooms. She just bought some mushroom spores and grew them solely on these actual plates. And after, I think this was like after 3 weeks. Yes, 3 weeks. She's pulling out 41 parts per billion onto the mushroom. And she also started up a new worm farm as well. Bought some brand new worms, and these worms are solely eating these sugarcane plates. And you'll see there, obviously the worms have a background, like we all do, of 1 part per billion. But I think this is just after 3 weeks as well, with the TOPA, the worms themselves, we're testing the worms, have shot up to 53 parts per billion. So it is going in through the food chain as well. And my last slide, we were a little bit mixed up, and I won't go back to stuff it up, but we did before this session, we did a blood test of the presenters, and I won't go back there. So PFAS, I have 6 parts per billion in my blood. David Burns has 6 parts per billion, and Shemaine has 3 parts per billion in her blood. So it is in everyone's blood. Everyone here has it in their blood. And those levels are we've done a lot of blood testing. Those are the levels that I would expect. So I work in an office in the laboratory. I have no exposure except everyday exposure like most of you have. That would be the 6 ppb, and that's a really average result. And for women, menstruation means they're always going to be lower. So generally 30 to 50% lower in the blood results. So yes, in everyone's blood and everywhere, basically.
Wow. All right. On that cheery note, all right. So, do you guys want to try and come in, or we want to try and get some more stools? No, maybe. You okay standing? You're all right. Okay. No throwing peanuts from the gallery though. Right, so we kind of maybe launch into that a little bit quickly, right? And I guess, what's the knowledge of PFAS in the room? High? Medium? Low. All right. I guess we wanted to do this session because we had lots of great speakers, but also to maybe alert, not alarm, right? Because I think there's a lot of conversations about PFAS at the moment.
Yeah.
And we're about to watch the polluting the planet, and everyone grew up with Aaron Brockovich, right? And it's kind of hard, right? Because I think we heard a lot about Williamstown and settling the court cases, and it's still unclear, I guess, in my mind, how harmful PFAS is. Right? I went to an alga conference, Paul Lightbody, if anyone knows him, tricked me into presenting about a topic I knew nothing about in my first 2 years at WAMA, bastard. But I did remember having the Department of Health there,
Yes.
and they were actually going, no, the research says it's not as harmful as we think, right? But I guess the challenge for the waste sector, as the recipients of this, you get really different and conflicting approaches to it.
Yeah, exactly. And that's it. That's the confusion out there. So the Commonwealth Government, their advice still is that there is not enough evidence out there. Some other overseas departments are saying there's more evidence. So issues with cancers, cholesterol and gout issues, reproductive issues, all the usual things you'd see coming up. There is a lot of, like Gayle said, there's a bit of scare tactic out there. To me, I have no issue at all in eating food out of one of those bowls, because if you sell me a hamburger and chips in a sugarcane bowl, well, that's going to be scoffed down in 2 minutes. I'm sure that is not affecting me. My problem is this is then going into either refuse or into compost, which is then leading to other things. So breaking down and entering the food chain, basically. But yes, still a lot of confusion out there about health advice. And it is a problem as well for a lot of the firefighters. You might get a blood test result that is very high, and that can be a psychological issue. and people panicking about it. Yes.
So the levels, what's the safe, understandable level in the blood at the moment? And can you, does your body break it down? And if it does, what sort of period of time? So I've got a few questions to ask. And
Okay,
is
I'll
there a
sit
process
down.
or
I'll
something
leave
you can actually take to reduce it in the blood as well? Is it curable, so to speak?
Yep. Let me just find that blood. That just the slide. Oh, there we go. So there it is. So
I've done this joint, so I want another option.
okay. So here are our results.
But then you won't be able to compost that either because it'll be too high.
That's it. So there is no guideline for the blood. What the Commonwealth is doing is using a 95th percentile. So in this case, the guideline for the three of us, you're much younger, but we're all lumped into that, whatever that is, 30 to 55-year-old age group, is 10 ppb. So that means that 95% of the population will be less than 10 pp and 5% of the population are over that. So if we do this testing in fireys, we'll find the younger fireys are all low. They'll be very similar to my results. But the older guys who've been there for a long time and using these products, they will be a lot higher, up, some of them up into the thousands, they'll have it. So yes, so there have been some things. South Australian Metro Fire is a really progressive fire brigade. They're doing some trials on plasma donations and also a cholesterol drug as well. And that research is going to be published, but both of those things are working. So it's not breaking down the PFAS, it's just eliminating the PFAS into the sewerage system, which will then get spread onto land.
Sorry, I just want to do a tiny little bit of a sense check here for all womankind.
Yeah.
I'm not sure if a lot of the men realise how much blood you actually release when you're menstruating.
No, I don't know.
About 2 tablespoons.
Yep.
So if you're saying 2 tablespoons of blood 12 times a year is enough to decrease your blood PFAS levels by 50%, we should all just be stubbing our toes once in a while. I wonder if that correlation is a bit of a stretch.
Yeah, well, it could be. It could be. So yeah. So the literature says 30 to 50% less. So who knows? But
Very interesting correlation.
yeah. But certainly the results that we have done, it does kind of match up with that. Yeah.
So it does, from a council perspective,
Mm.
the waste management in the coast, we looking at implementing photos.
Yep.
Either, I suppose, nervousness.
New South Wales.
Yeah. There's an even nervousness amongst the elected body because of the stuff they've seen around PFAS, and unsure how the EPA are going to react long term.
Yep.
And that's a huge risk for us because we're looking at investing in tens of millions of dollars. So from your perspective, obviously, by the sounds of it, you believe that there should be a review and the identification of a risk-based approach at the safe level for organics, so that we can then reuse these products because we have risk-based approach across the whole sector.
Yep.
We're not going to be doing that.
Yep, I think risk-based is very important to do. I think it's terrible that all these good biosolids are ending up in landfill. I think more studies need to be worked out. Who knows? So if a guideline might be 2 ppb in compost, maybe that's all right. I don't know, but yes, probably it needs to be risk-based.
But just to clarify, right, New South Wales has not got that level of 3 parts per billion.
No,
And
yeah.
New South Wales is actually actively saying that they're not going to put in a level, right? We're actually going to work with composters to address the concerns about it. I guess we do need a consistent approach. One thing we were waiting from, and I got that at the end, was the NEPM review, right? And so, we all know that we duly got our submissions in by February last year, and they're tired working through them. And we still don't have clarity as to, literally someone told me that the other day, they're really tight because they're overwhelmed. Oh my God. They did have a table of the risks, all right, and I think biosolids were 3rd or 4th on the risk, but we don't have a level as yet, right? So at the moment we're still continuing on with collecting and processing, but I Queensland really knocked us for six with their completely unreasonable approach to the 3 parts per billion for the output. And the TOPA, I guess, does the TOPA strengthen it? Like, because they all seem to go up. So how
Well,
does TOPA work?
yeah,
We
so-
have to now do TOPA, which we never did.
Yeah, so the TOPA technique where we're oxidising it is just pulling out the PFAS that a lab can't normally see, and we're converting it into a compound that we can see.
So the trouble with this threat is that, you know, we put material in bins, we put them in trucks, we take it to a facility and the material keeps coming and we keep adding to the piles and, you know, then we now get testing probably on the way in and the way out. And you just try and think about how does that logistically work from a site size and a cost size, you know, it's just insane in the brain, right? And this is our challenge, right? Because we go from a processing cost and a collection cost to also now testing and sampling, and then the market development piece is so challenging, right? Like, but we don't make it, we just take it. But it doesn't apply in South Australia, does it, Grace? You don't have a problem with PFAS over there. So what was your question?
Oh, I was going to ask, it's probably to you, Gayle. Has there been data on the compost since there's been no compostable products in the green bin?
Well, the only state that's clearly not got anything for a period has been Queensland. Like, they actually started theirs with no packaging. Yeah, they started with no packaging. New South Wales started with no packaging, but councils interpreted it to have packaging. So that's only had no packaging since December 2022, I think, and I think it's been a gradual rollout. But my understanding, so we are still seeing levels of PFAS in organics in the photo as well. I think there's leach. Is it like osmosis? Can it leach as
Yeah,
well?
yeah, exactly. We'll find it in landfill leachate as well, obviously. Yep.
So,
Of water added as well.
well, that was the great thing about the Queensland work that we did. Queensland's actually done a survey of the level of PFAS in its stormwater, and the only place that doesn't have PFAS in its stormwater is the remote part of Queensland. So we're all moving there to do our organics because we couldn't for the life of us work out why they sent us that document to actually highlight it was everywhere. But there's like one tiny patch in the rainforest in FNQ that doesn't have it. So can everyone just send their organics there and don't use anything other than stormwater from there under the gun? It's nuts.
Exactly.
Harry, laughing? Just crying? All right. Any more questions for David S?
Have you done
Yep.
studies on the background in drinking water and what the PFAS levels are?
Yeah, we have. We will offer, so we can go down to 2 parts per trillion. That level. No, you didn't do 2 parts. 2 parts per trillion is 1 second in 160,000 years. So back when you're at 8. So that's what we're levelling, but we're looking at in low level, and we will find very low levels in a lot of
And isn't that what US EPA just came out with drinking water? That was the level they came out 2 weeks ago. 4 parts per trillion. Oof. So back to the caveman almost.
Yes.
Okay. It's insane. All right. David.
Thank you.
Another David. Here we go again.
Okay. So, thanks, Dave Springer. I guess what I want to do today is to move on from Dave's conversation about showing where PFAS is, like which products it's found in, who and what are the passive receivers. So thanks, Dave, for confirming that you and I, we're passive receivers, and we're probably not going to be able to travel to Queensland for a holiday, but Charmaine, like, you're going to be okay. Yes, it's quite a complex thing. So once PFAS is integrated into a product at a manufacturing site in another country, our government gives permission for that to be imported into Australia. So that's how it gets here. We don't make PFAS in Australia. It all comes in. So in regards to that, I guess we're all passive receivers because we don't make it. None of us are applying it in a firefighting application at an airport. In this sector, we're passive receivers. We're trying to deal with the waste that's come from others, and it creates a lot of confusion. So what I wanted to start with, first of all, was just to define what Dave mentioned what PFAS was and how much is in a product that has PFAS. What I wanted to bring to your attention is when you go into the shop and you see a label claim on a product like a saucepan or a whatever, and it says PFAS free or PFOA free, what does that mean? Does that mean there's zero PFAS in there and that there's no risk once that end of life product goes to a landfill, comes through the weighbridge and is put in a solid waste cell? That's not what it means. That just means that there's a voluntary code somewhere that there's less than 100 ppm, which is 100 million nanograms per litre, or 100,000 ppb. So remember, Dave and I, we're not allowed to go to Queensland anymore because we've got 6. PFAS free on a product means it's 100,000 ppb. It only has to be less than that number to be PFAS free. All that stuff one day will come through the weighbridge of a landfill and be in the solid waste cell. Or it gets flushed down the toilet, or it goes to a facility where there's a trade waste facility and it bypasses the landfill and it goes directly to a sewage treatment plant. But what I'm about to show you is how the sewage treatment plants are linked to landfill operations and linked to compost. And what I really want to show you is how the waste network is being used to, I have to assume unwittingly, disperse PFAS from concentrated levels through the waste network to be dispersed as low level, which means it's too expensive and spread too far to do anything about. And those levels way exceed the levels that the Europeans and the US are saying is unsafe. So there's a couple of dot points there that you can go through. Those things also have other complications, especially for aspirations for governments who want to divert 80% of waste to landfill. It's hard to do that when there's PFAS contamination in it, or there's asbestos contamination, or there's some other toxic chemical contamination. It's hard to divert it to recycling. Can't really do it. Where does it go? Gayle has said that Australia could become a dumping ground for PFAS in the future if we don't have criteria. But I'm about to show you that landfills are already a dumping ground for PFAS, not from overseas countries where they send their stuff where they can't sell them, but from the contamination industry in Australia that has really tight regulations. They dig up those source zone concentrations, and to get rid of it, where do you think it went? To the cheapest option, which was a landfill. So that concentrated PFAS in soil at a firefighting location on an airport or a defence base has been dug up, including the concentrated resin or GAC. It's gone to landfill. That's now in a landfill cell forever, that will forever leach really high concentrations of PFAS in the landfill leachate, which is actively pumped out to a sewer connection, which will end up in a biosolid, which disperses everywhere. This is what we need to know what we're dealing with before we come up with solutions. If I go to this next slide, I just wanted to give some quantitation about the numbers that are applied to some sectors, which in a way is quite unfair, especially for your sector here, the landfill and sewage treatment plant and compost sector, compared to others who have no regulation apart from a voluntary one. So that top line basically shows that PFOS and PFOA can be 100 million times higher than the criteria that's applied to landfill leachate in Queensland, or many thousands of times higher than what's said to be safe to drink water that has PFAS or PFOS or PFOA or PFHXS in it here in Australia. So there is a massive disparity between how regulators, the government here in Australia, apply a set of criteria on one group versus another group. and I agree with Gayle that it should be a uniform approach, a whole regulatory system approach. So I think these slides are being made available to everyone, so I won't go through that because it's quite detailed, but you can have a look at that later to go through the details. Just before I leave my soapbox about what goes into a landfill, I just wanted to mention that I read with interest an article in this month's Waste Management magazine that Mike Ritchie wrote, and he was basically posing a question: should landfills be contaminated sites? Well, they should. There's so much PFAS being sent to them over the last 20 years that they are a contaminated site, and the operations in a landfill, in a sewage treatment plant, in a composting situation, if PFAS is deemed to be harmful to human health and harmful to the environment, at certain levels set in Europe, America, what we think is going to be said in the NEPM, then it must be for PFAS alone, let alone other chemicals that we're not even talking about here today. Typically, what I'll harp on the landfill leachate and landfill design criteria at the moment, like landfill operators, their focus is to protect groundwater, surface water and soil under the landfill cell. There's typically no criteria, regulation, effort to treat the leachate by regulation. If it is done, it's because it's being done by a company that has a moral compass and they're doing it anyway. Or they might have a special trade waste condition put on them. I'm a member of the ITRC in the United States for PFAS treatment and remediation. It's a group that it comprises academics, US EPA, state EPA, consultants, contractors, whole heap of people. They're now really concerned about any time you aerate water that contains PFAS, that you're creating volatile PFAS and aerosolized long-chain PFAS, which can travel hundreds of kilometres away from where you conduct that aeration, specifically when the aeration activity is open to the environment, e.g. a sequential batch reactor that converts ammonia to nitrite, then to nitrate for a sewer disposal licence with the Water Consent Authority. Typically those aeration ponds are a sewage treatment activated aeration pond, but they're not in a building, they're not contained, it's open to the atmosphere. It's my personal belief that the majority of people who have exposed themselves, firefighters, to PFAS, they've done so because they've inhaled volatile or aerosolized long-chain and short-chain PFAS without proper PPE. Like they've taken their PPE off probably 2 minutes after they finish their training, but aerosols hang around in the air when there's no wind for hours. So you're going to inhale that.
Make a point there. Most firefighters in a bushfire scenario don't use PPE. So if they're at a structure fire using foam, historically they would have used BA, but now.
Yeah. So my background is analytical chemistry, like Dave. I cut my teeth in the lab. I would never use PFAS without full PPE in a fume cupboard. I just wouldn't do it. I do pilot studies. I'm one of the co-inventors of the SAF system in the big blue 40-foot shipping container here. When we've done our pilot testing, like I'm masked up with a Draeger full face mask with big cartridges hanging off the side, like I'm not going to breathe that air. That system in that blue container, it's a self-contained system. All the exhaust gases go through carbon cartridges, because we know if you vent to the atmosphere, air is another pathway for PFAS exposure and mobilisation. It's not just water, it's not just soil, it's not just food or waste. It's air, and another one that's starting to come up is, as Dave said, when we disperse PFAS through the waste network and it gets to biosolids and they apply biosolids to farmland as a soil conditioner, we're now worried that the farmers that are pulling these massive agricultural tractors and putting up huge dust clouds, they're sending PFAS in dust across the whole community.
Sorry, so what's your thoughts on all the women that have all the eye makeup that they put on every day that has 600 ppb and all the foundation and the lipstick and we still have lower blood levels than the men? Like why are you so concerned?
Because PFAS in air is a direct pathway into your lungs and into your blood. But it's going through the skin. The skin's a pretty good barrier.
Liquid, your eyes are aqueous based, right? So it's right there. It's not such a...
The studies show that even if you have PFAS in water in high concentrations and you get it on your skin's a very good barrier. But I don't know about the eyes. Yeah.
I think that's the fundamental, right? We're unclear really what the impact is, but what we see as a sector is we're continually told you can't make products with it. And so I guess that's the question. Is it dangerous or isn't it, right?
Yeah.
And if we're going to keep getting, at the end, you cannot put a product back on market and we're showing products ad infinitum with levels way beyond what we do. What is it? Is it a problem or isn't it? And give us clarity.
Yeah.
And I think that's the fundamental question that we're trying, like, we can't solve that today, but we're highlighting the challenges, and I guess it's that constant challenge that recycled products are subjected to standards and regulation and enforcement that natural, virgin, other products are not. Right? So we can't go circular while we're talking, when we've got all these hazardous materials quite happily placed on shelf. Go to Priceline. Buy as much PFAS as you want, people, but do not make any compost on it, whatever you do.
And yet you can buy cosmetics without fluoride in there.
Can you? How much that cost?
I can't see the ingredient label, so
Yeah.
we have
You're no good.
and there are PFAS free zones. So that's why I was saying look for that, look for the F chemical somewhere in there. But I agree with Dave that the studies show that the dermal is a lot less. You're going to get more in drinking contaminated water and eating contaminated food.
Yeah, but this is just a man thing. Yeah, your eyes
Are you just saying we're tough again?
Yeah.
Turn up on time and we're tough.
Yeah. Well, what it could be is that the amount of PFAS that's in cosmetic is way, way less concentrated than the amount of PFAS coming out of a firefighter's hose as foam that they're directly inhaling through their mouth into their lungs that goes directly into their blood to every organ of their body.
You clearly haven't had a makeup party. I would say you don't. But I think the point also, back to what Janice was saying, is there's not a label or a way of knowing as a consumer, right? And today's brief was to alert, not alarm, David, so come.
Sorry.
The point is that I don't have any clarity as a consumer when I go, do I look for the ad? Is it of concern to me? What should I be looking at, and how do we get this message out there, right? Because we have a real habit of scaring the community about recycled products, right? Which, undermines all we're trying to do, but we're not actually equipping them to deal with non-recycled and impacts, right? So I think that's the conversation we really can keep having.
Yeah.
And take this knowledge from here back to the community. And also say to government, is it dangerous? Can you tell us, right? Make a decision on this stuff. You can't be half pregnant.
Yeah. So my opinion, so as a chemist, like I've been dealing with chemicals my whole life, and I'm cautious when I'm using them, the precautionary principle. So this slide, I've got 2 slides left, this one and the next one. So the thing to remember is, as you go from this slide, from the factories that make this stuff, to people who apply them like a firefighter at an airport and becomes a contaminated site, you're talking about concentrations of PFAS that are extremely high. And there's real anecdotal and other toxicological evidence that shows that is hazardous, that is dangerous. As you move from the left across to the right, as PFAS goes from factory to point of application to contaminated site, dig the contaminated soil up, send it to landfill. When all of our products that have PFAS in them go through the weighbridge and they get buried in a landfill cell and become airborne, or they become landfill leachate and they get disposed to sewer, the concentration is becoming dilute. However, in the curbside waste collection, like all that dilute PFAS is being collected and aggregated from millions and millions of homes to a more concentrated aggregation point, which is the transfer station or the landfill. So although it's becoming dilute, it's also, we're concentrating it at the same time, or aggregating it. Then once all that stuff's in the solid waste cell at a landfill, it typically concentrates 10 times more as all the stuff in the cell forms liquid from either rain or just forms its own liquid because it's waste. And we pump that out so the waste bathtub doesn't overflow and flood the surrounding environment. We get fined by the EPA. We pump it out and it either gets taken by truck, or hauled by truck, or a direct sewer connection to a sewage treatment plant. When it goes through the sewage plant, it gets concentrated another 10 to 18 times by the time it ends up in a biosolid. So the issue is, when PFAS starts off as being really concentrated and it gets dispersed through the waste network from dilute, it reconcentrates up to be, I think, hazardous again. So that's why we've got to do something about it. Now, should it be this sector's issue that they pay to do the treatment or do something about it? When it's everyone's problem, we're all passive receivers of it. The government, they brought it in, they let us buy the stuff. Why are they now putting these really low, stringent conditions on one sector when another sector has no criteria put on them to do something about it? Oh, that's unfair, I think.
Yeah, life sucks.
Yep.
Kids every day.
So remember that slide.
For us too, is in Queensland, we have all these targets that we have to achieve. Where I know a lot of us are putting in pogo trials, trying to sort of get there, and then the government just introduces this really.
You never will achieve them.
I know we're not going to, and because in one.
Don't quit.
No.
I may be
Yeah.
retiring, Gayle.
Yeah.
Exactly. Do it before you go, Gary.
So, so some of the big brands, they have committees, they have steering committees with their CEO on them. They're trying to work out, how are we going to comply with this?
We have to actually move the conversation to the end of the chain to the start of the chain. It's so obvious, right?
Yeah.
Like, we've got to stop going, we're going to fix it at the end. And part of it, I don't know if I've said it here, but I feel like it's record. We've got to stop solving everyone else's core design issues and start saying, hello, stop making it, and we've got to stop making it, right?
Yeah.
And I know with asbestos and PFAS you can't see it. How do you say, I can't take it because I can't see it? But
Yeah.
regulators, if you're so sure that we can't take it, you stop it.
Yeah.
Like, we have to get more vocal, and I guess we are our own worst enemy because we keep going, oh yeah, we'll solve it. There's already somebody who'll go, I'll take your shit and solve it.
But aren't we getting vocal, Gayle? Isn't that what we're doing?
That's all I
How many times do we send the same letter to Desi to say these are our issues?
Well, I guess you'll have to join me, right?
Yeah.
The pro formas are on the website, but and I guess like PFAS became a really big issue for me in South Australia. Grace, thank you guys, and this table over here. When Resource Co tried to put a landfill that was categorised to accept PFAS in an existing site near McLaren Vale, and they were told you can't put it into this landfill. PFAS, a purpose-built cell, you can't put it in there because it's near the wineries. So we tested the soil nearby, and guess what? I didn't say it, right? So for about 2 years, SA did nowhere to take PFAS-containing soil. Anything, sorry. So, but if we were to test our garbage bins at our curb, we have PFAS in it, right? Because we're all buying it. So how do we, as councils, We don't have enough conversations around, no, we'll put it in your bin, but don't buy it. Don't take it off the shelves and then don't put it in our bin, right? These are the conversations we need to be having, not, oh, does my plastics go in the yellow? Like, let's stop buying the plastics with the PFAS in it, yeah?
Got one more slide. So, this slide is where PFAS starts, and as you move to the right, it gets more concentrated. This next slide shows how where we manufacture PFAS travels through the economy that's regulated and unregulated. And once it gets into the waste network, we've created two passive waste loops. One that exists between the landfill and the sewage treatment plant, and one that exists between composting and the sewage treatment plant, and the sewage treatment plant connect them both together. So it's a bit of a complex slide. So I'll break this up into 4 different groups. We've got the green bin. As we heard, Dave showed you that container's got PFAS in it. So PFAS is always going to be in your compost, and it's always going to be in the leachate that the composters create, that they send that leachate water to the sewage treatment plant. The next one, I'm going to put my glasses on.
We're getting old.
Industrial commercial wastewater, that goes directly to the sewage treatment plant. We've got trade waste, which can have very high concentrations of PFAS, like scrap metal producers, galvanisers, all that goes directly to the sewage treatment plant. PFAS is not a chemical that's in a trade waste licence agreement.
It is in Queensland, I think.
Typically it comes, it might be in Queensland now, but
Every PFAS is in Queensland.
traditionally PFAS comes under this thing called other compounds, and you just have to be under, I think it was 1,000 ppb, 1 microgram per litre, 1,000 ppb. So that's really high to be under, and everyone's under it. So there's shitloads of PFAS going to the sewer. Then we've got the 4th one, which is the red bin. That's all the stuff we put out on the curb. We know what's in that. That's going to landfill. Leachate goes to the sewage treatment plant. But you've got to remember that the solid waste from the sewage treatment plant, the biosolid, or other unsellable solids from the compost, they send that back to the landfill to make more leachate. They then send that. You have these pervasive loops that you never get rid of this stuff. It just cycles through the waste network. And eventually, the sewage treatment plant, they want to obviously make money. So look what they're doing. Like, they're selling biosolids as a soil conditioner and sending it to farms. They're putting it up as dust clouds. There's aeration going into the air. Like, the waste network is being used to disperse PFAS everywhere because there's no criteria.
You missed that memo about alert, not alarm, but anyway, keep going.
But I think this is what has to happen. Like, we have to explain this, that we're passive receivers. If DESI and the regulator wants to control where PFAS ends up, you have to find a point downstream and upstream of how to manage it. So upstream is trade waste treatment. It's banning new PFAS imports, but there's so much PFAS in people's homes, in their businesses, in factories that haven't even become waste yet. We're going to be having PFAS come into landfills and sewage treatment plants for the next 50 years. So you have to have waste treatment at the landfill before the leachate goes to the sewer system, and you're also going to have it in the sewer system. You have to, which sets up a question for Gayle and your sector. Who pays for this? Because it's super expensive. And I just wanted to give you one last fact and figure that in the United States, a company called Bar Engineering were engaged by the Minnesota Pollution Control Agency in 2013 to financially forecast what it would cost to put a treatment system in for all drinking water, all landfills, all sewage treatment plants to remove PFAS below these low levels, like 1 to 3 parts per billion. It came back, and Minnesota has 6 million people. That's like the size of New South Wales. $14 billion US. And out of that 14 billion, over 110 million US dollars was just for landfills. Like, how do you pay for that?
Well, we're all paying for it, and the planet is too, right?
Yeah.
So how do we stop it being made?
Yeah.
On that cheery
Thank you.
note, any questions for David?
What
Yep.
happens to leachate that's evaporated? Does it get contaminated on the PFAS, or does it stay?
I don't think anyone knows about on that. Like, I know with aerosolized PFAS, like if you have a system that aerates water and it's open to the environment, and you're using very, very small micro or nano bubbles, and those bubbles burst at the surface, creating fragmented aerosol air-water interfaces, they're loaded with long-chain PFAS. I'm not sure what happens with evaporation with volatile PFAS. I don't think, to my knowledge, anyone's done that work.
There's some work going on with gas and PFAS, landfill gas. There's a presence, I think, recently in America. People are nodding. Paul Lightbody and Stuart were over there recently, and they were saying that PFAS was showing up in the landfill gas. So I assume that they're beginning to monitor it, and it may be the gas, or it might be the leachate evaporation. But I guess it's just everywhere, right?
There has been in a few papers in the landfill flare gas off-gassing,
Yeah,
that there's trace levels in that.
yeah, yeah.
Can I ask one more question?
Yeah, of course.
Might be a question for you, David. Does the linings that we line our landfill cells with, they would have PFAS in them?
Charmaine's going to talk a bit about that. Don't read ahead. Don't read ahead. But we will get to. We're going to talk a little bit about liners and treatment of it. I guess we did have a conversation amongst ourselves though about modern day liners are designed, but I guess it's that historical issue, and I think PFAS is possibly no different to other pollutants. You know, circular economy is where we design out waste and pollution. It doesn't start at the end when you give us your waste and pollution. Can I just remind everyone of that? So if we designed out the waste and the pollution of the products we put in, we wouldn't be dealing with this. But because we haven't, we've got a legacy material, be it asbestos, PFAS, you name it, that we're going to have to keep dealing with. That is going to be our constant challenge, right? Girl behind in the white, yes.
I was just wondering, you mentioned those systems that remove the PFAS. How is that happening and where's it going?
So that's Charmaine. Again, stop reading ahead. Just calm. Any questions for the boys before we get to Charmaine? Yeah.
Just one, and a comment. So,
Oh, I don't know about that. The comment went awry at the last session.
yeah,
Right, go.
Gayle makes a really, really good point.
Oh, thank God.
It's about designing out, because as local government, one of the biggest problems we have is state government pushing costs onto local government to deal with the end result of what's approved by feds, what, in design, state design, all that sort of stuff. It all comes through the system, we end up dealing with it. And then someone like yourself, who's very intelligent, obviously, knows the subject matter really well, makes a presentation like that to someone from the EPA, probably doesn't understand it as well, and then people get really nervous and people will make knee-jerk reactions. And I know that's not fully happening here in New South Wales, but around our water authority it is. So the EPA talking with we're our water authority, they are talking with us about you can't send your leachate directly to the STP,
Yep.
but we can put it in a truck and dump it there.
Just don't tell them.
Yeah, it's just ridiculous. But yeah, I suppose, like from your perspective, how do you solve that issue? Like apart from spending millions and millions of dollars, tens of millions of dollars on treating landfills, and the space issues, historic issues with site construction.
The same dilemma is being faced by every organisation worldwide. Everyone. Like the PFAS issue is worldwide. It's in every city, every town, every little hamlet. It's everywhere, and everyone's trying to deal with it. And at the moment, there's expensive solutions. Like I guess like one. I didn't get to mention it in that chat. That there's a paper that got published was sponsored by the US EPA, and it's talking about that when waste comes through the weighbridge of a landfill, the don't mix that with green waste or biological waste. And so like mattresses, carpets, construction, demolition.
But all that it does is reinforce why we've got to have separation at source, right? Because you can't in a mix like, oh, this truck came from Udadapto, so we've actually got to have increased separation at source to understand where it goes correctly.
What this paper found, that's sponsored by the US EPA, is that green waste, and it's biologically active, that will accelerate the removal of PFAS from your C&I, your disaster waste, into the leachate faster and more of it, which is meaning you're going to fail the criteria if someone's sampling and testing your leachate for a trade waste disposal. And in the absence of a trade waste disposal, like criteria in the NAPA, as you said, the water authorities, they'll become a Clayton's criteria regulator, because they don't want the PFAS ending up in their biosolid, because then the hot potatoes gone from the landfill operator to the sewage treatment plant operator. No one wants it.
I think that's the challenge with our system, though, right? Like, so PFAS for EPAs in the state is arguably, and I guess this is the problem with our model full stop. EPA's head of power is regulation of waste, right? So they're not market development agencies, and that's why a number of jurisdictions have separate ones, because when the only tool you've got's a hammer, you hit everything. But they don't have responsibility over products placed on market. That belongs, well, importation is feds, yeah? So again, it's really hard to regulate because it's outside of their remit, and we don't take a whole of government approach to products and materials. Like, we are still very much, even though it is 2024, I think, if we walk outside, we still very much see this as a very linear rates, roads, rubbish sector, and we're not seeing it as an industry and environmental sector, which is, I guess, what Netherlands talks about more of than we do. Like, we have to design not just for environmental impact. We don't design for human and environmental impact, because that's why we've still got PFAS going into packaging and makeup, and we're talking about banning 4 of the 28,000 next year. So if government thinks it's such an issue that doesn't need to be addressed until next year, and we're only banning 4 that Europe banned in 2009, then it can't be a problem, right? Queensland? All right, Charmaine's going to talk to us about how we can deal with this material.
Yep, so my role today, just to give an overview of what we could do. So we talk about what PFAS is, how it circulates within the community and the waste network. And so we all know how the pathway is. For instance, the airport, it goes through relocation of contaminated soils or through stormwater or groundwater when there's an overflow. And at the end, we are the receptors of it. What are the standard practices that we currently go through? So in the NEMT, there's a couple of things. You can do destruction technologies, landfill disposals. There's also remediation techniques. I won't talk about destruction technology because that's pretty much incineration. Experimental is still ongoing. I would like to highlight 2 practices. One is the landfill disposal, which we've been talking a lot today, and also what are the remediation techniques that we can also put into the system. So like what David said, a lot of things goes to the landfill, and what do we actually have in the landfill system? What is typically built layers after layers? So typically the structure of a bottom lining of a landfill, you have mineral liner or a GCL, which is geosynthetic clay liner. You have a geomembrane, which is a thick plastic. You have a non-woven geotextile that acts as a protection against the geomembrane. Then you have perhaps reinforcement required, and then you have a drainage layer and then another non-woven layer. The lining system generally would vary between different states. Sometimes you have dual composite system, sometimes you have single composite system. When I mean dual, which means you have double of what you're seeing right now, or you would have a single combination of what you're seeing. So, and I believe in New South Wales for the landfill for looking into the PFAS, I think there are different regulations for single and composite liners, dual composite liners. But the question is our current landfill system capable of dealing with PFAS? So we're dumping stuff on top of it, and we know that in landfill system, there is always leakage issues. No geomembrane is going to be welded 100% correct. I do believe in, I think, Victoria, there is a certain percentage of leachate allowed into your system. So which means we can all agree that we do have leachate somewhere, somehow. So that's one thing when you have a system that is actually not dealing with it 100% no leakage. But some people assume that it's going to be 100% okay. Let's look at literature and see how does the geomembrane deal with it and how does geosynthetic clay liner deal with it. So there are a lot of literature that actually looks into geomembranes and also just geosynthetic clay liner. And what they realized that even though in a perfect HDPE geomembrane, the crystallization of that membrane itself during the manufacturing process could also be imperfect. And our little forever chemicals would find the smallest way and whatever way that they can find through the geomembrane to get out. So that's one problem. And the other problem, as you can see on the graph on the right, is three types of PFAS is being evaluated. One with just original leachate, then geosynthetic clay liner. And what you can see that the GCL actually doesn't stop the PFAS. It doesn't retain the PFAS because it's never meant to. It's a clay liner that it replicates a clay liner naturally, which means it only actually inhibits permeability. It's low permeability, but it's never to function for PFAS containment. So if you can see on the results, when PFAS comes in, there is no retention. There is not the function of what a GCL is. What you can see here is also interesting is a activated carbon GCL, which is a common binding material that is used to deal with PFAS. But recently what we also realized is there are a lot of literature studies now, given that activated carbon is a very popular practice to actually deal with PFAS. We realized actually when you use activated carbon, PFAS numbers actually, there's a higher concentration value goes in. The reason is because activated carbon is very good with long chain PFAS, but not very good with ultra short chain PFAS. So what happens, it goes in, what you'll do is you see in the next slide, initially you have a very high results, but then you have the long chain PFAS turning into short chain PFAS. So you have a way higher concentration after going through activated carbon, for instance. This is literature review, so it's not me putting out that. So you can see there are a couple of papers that actually look into activated carbon as a system. But bear in mind, activated carbon does deal with PFAS. I mean, it's able to remediate, but just not all types of PFAS. So you just got to make sure what is long chain, short chain, and what your concentrations are actually at. So what do we propose? So as you can, we've been talking a lot about different remedies and stuff like that, but talking to people, gathering people, but what can we do right now? So what I propose is actually a tactile active PFAS is actually a geosynthetic material that has an active ingredient in between, similar to GAC, but what we have is a PFAS absorbent media instead of using GAC. So
What's GAC? David said it too, and I don't know.
granulated activated carbon.
Okay.
Yeah.
Keep using acronyms. GAC. Right.
Yeah, so this is a material where what happens is that it actually binds the PFAS in the system. And what we recommend to do is actually have a liner into your landfill system. So when you have your leachate going through, as what David mentioned, a lot of stuff actually goes through to the sewage system that has to deal with it. So if we can capture it in our existing landfill system, where you actually have the leachate or PFAS leachate that goes through your landfill, is actually captured in that layer, and whatever comes out, it's clean. So in that case, you reduce the step in dealing with the downward remediation section. So it can be applied not only just for PFAS. So different active ingredient can be used for different applications. So, we have so much contaminants, right? So PFAS is one major of them, but we can also look at PAH, heavy metals. All these different contaminants or emerging contaminants can be dealt in the same concept, put it this way. So this product is very efficient. I'll show you a couple of results in the next couple of slides. We've done some testings in Germany and also in Australia, so we look at the remediation capabilities. So out of whatever 28,000 of PFAS that we have, we look into the 6 most popular PFAS, and what you can see here is sorption and desorption. So what's important that a lot of system is able to absorb, but we also need to make sure that it doesn't desorb. So certain times we see certain solutions, they're capable of absorbing PFAS, but after a certain time, for instance, it changed to an ultra short chain, then it desorbs out of the system. So absorption is important, but desorption is also important for an evaluation of the system when you come to deal with PFAS. So we've done that on the contaminant sites in different intensities of wet and dry soil with different rain simulations. So we have 10 liters per square meter for 60 minutes, and intense rain, 30 liters per square meter, and that's how the results are being accumulated. And yeah, so remediation of the system has been tested and proven. Not only just for landfill lining application, you can also do it for stockpile. A lot of sites that we currently deal with PFAS, there's actually no place to actually put them. You can't excavate it, you can't move it, what do we do with it? What we like to achieve is actually able to reuse contaminated soil. So for instance, if you're building a reinforced soil wall, we can actually put the PFAS, tactile PFAS lining at the bottom. It captures the contaminated material PFAS in the textile itself, but then you can reuse that as a fill material, and that's not waste material. Right now, you got to put it somewhere, landfill or incinerate or clean it up before you can actually do anything about it. But so it's just many options that you can use with the material instead of just using for landfill lining. So securing stockpile materials, sediment capping. This case, for instance, sediment capping, we did it not for PFAS, but this is Kendall Bay in Australia where they couldn't actually dredge the material. So instead of dredging it, they actually just cap it. So when the material goes through the geotextile itself, it's been captured and not released back into the environment. So that's that's the benefit of having a system that is very flexible. Also, like landfill system in Germany, where in this case I think they have a 3-layer composite just to be able to deal with the PFAS in Europe. Lastly, a lot of times people always ask about how much it is and how efficient it is, or how do you work out what's the benefit of it, because people often look at the cost of the material and say, oh, this is super expensive. But I always like to address is how much soil can you actually remediate versus how much is the material cost. So if you can work out how much contamination that you can actually resolve rather than just having truckloads of material being disposed and incinerated, that's the cost that we should be looking at, not the cost of just, oh, this material is like really expensive, in comparison to just dump activated carbon on top or try to aerate it. So in this case, for instance, we're only assuming a capacity of PFAS being taken, and you can see that thickness of soil is 7.3. If we assume 100% of using the material for uptake of PFAS, that number goes up by 4 times. So it really depends on how you actually look into the problem. So it's not just cost of material. I like to look at the overall solution of what you can achieve by using this material. And obviously, it always is very dependent on the concentration itself. So it's not like a magic carpet where I put this in and everything is done. No, it's always something that we design, like we design any structure. It always depends on what the design life, what is the concentration, and therefore it's then, let's say, customized for that project. So you can see here we have a 2,000 and 3,000 capacity. So yeah, this product can have a range of value depending on, not range of value, have a different range of product capabilities. So we're not gonna offer you a one solution for all. It's always customized to your situation. So if you're expecting this amount of concentration, then we'll tell you that this is the product that's gonna be capable of dealing that for X amount of time. Therefore, then you can just use that. Which is also, I can't disclose where this location is, but for instance, in an airport, they want to deal with stormwater that could be contaminated. So what they do, they have a dual layer system here. So it's wrapped with geomembrane and also detector seal PFAS. So in case of there's any leakage whatsoever or a geomembrane not being able to contain, that material, contaminated water, will actually be contained with detector seal PFAS. So the water that comes out of the airport is actually not PFAS contaminated. So, which is pretty cool, I reckon. And I do believe that we should start looking into small solutions, little solutions where we can start implementing, solutions like that. Because we can only take the first step. It's not a solution for everything, but if we start somewhere, and then I think we will achieve much. There is also other solutions. We talk about different types of waste. If you guys are familiar with sludge dewatering, for instance, that could actually, during this dewatering process, what you could do is actually put the geotextile in the bottom layer. So as the water comes out of the sludge, it's actually also going to be remediated at the same time. So like you said, there's a lot of biosolids that's actually PFAS contaminated. So one thing you could do is also lay it at the bottom of it, and you also could capture the PFAS contamination. And then as the water go out, you have clean water. And sludge dewatering can be used in all sorts of application, from oil to wastewater treatment plant to paint, paper, meat, salmon industry. Sludge dewatering is applicable to everything. In managing emerging contaminants, as I said in the beginning, so we have different type of products that deals with different types of contaminants. We have PFAS, dissolved organic contaminants, metals, radionuclides, and oil and petrochemicals. These are the different types of solutions that we could use. So it's two textile with an active ingredient that is meant to deal with different types of contaminants. And like I said, the active ingredient is always dependent on what the concentration that you're actually expecting. So it's not a magic carpet. And that brings me to my last slide. Questions?
So that kit seemed to deal with addressing material in situ, right? A lot of capping, but we can also incinerate, right? Correct. So we're seeing, I think Veolia in Adelaide addressed the issue because there was a fair bit of PFAS in the water table at one stage out at Edinburgh Airport. So they did incineration. Logan Council's working with, is it Brisbane Water or Queensland Water? Can anyone remember? So that's the plant that they've built. Yeah. So they're doing biochar and incineration, I think. So there are other ways, I guess, of end of pipe destroying rather than keeping in situ.
Yes, there are other ways. Like I said, you can do incineration, but there is also the thing that you mentioned earlier. What happens during incineration? Is that gas coming out? Is it more actually safer to do that? Are we having more energy consumption doing that? What is actually the most cost-effective solution and sustainable solution? Do we want to always have, we talk about carbon, lowering on carbon footprint, but incinerating, is that really the best option? Is that the only option?
Well, I think it's a life cycle assessment, right? We need to get better at that. And biochar, like that, this is going to be an issue for biochar, isn't it? Is it?
I'm not
Nodding.
familiar with biochar.
Yeah, so there's a lot of biochar being created potentially from biosolids. So I guess the presence of PFAS, does that impact how it can be used, or I guess it's still good for carbon capture? You have to put your hand up, David. It's all right, you can talk. Yeah.
So I mentioned the ITRC, so US Interstate Technology Regulation Council of America. So October 2023, they just had about 300 experts around the world update every treatment technology, every destruction technology for PFAS that is commercially proven, has just recently become commercially proven, is going through an emerging proving process, and things that are still in research that will become available in 10 years' time. They've listed and rated every single one of these on their public website. And it's a free access for anyone in the world to go in and read it. It's the biggest aggregation of the most up-to-date information about how you manage PFAS, all the criteria in every country of the world, every state and region within countries of the world. How to treat, how to destroy. And in the waste management sector, and this also is backed up by what the biggest waste management companies in America say. So that's Waste Management, Waste Connections, Casella, HCC, Veolia. There's a handful of technologies that are the most important to remove PFAS out of sewage, out of landfill leachate, and compost leachate, and then biosolids, and they're all rated. I urge you to go and have a look at those, and obviously, like, liners are very important if you've got a landfill cell that you don't want to have stuff contaminate the groundwater and the soil underneath.
No, I'd do it at home, right?
Yeah.
No idea.
So it's a bionymic process. The air-water interface of a rising air bubble attracts the PFAS to absorb onto that rising air bubble that stratifies up because air bubbles are buoyant, and they spill over a weir or they get vacuumed off in real time as a foam. So this is in nature. Nature does that. That's why you see foam when you get big waves crashing on the beach. You see foam from how fresh water mixes with salt water. But on the Great Lakes in the United States that are surrounding the area where 3M and the other companies made Teflon, which use PFOA, every time there's a storm, you get all this foam washing up on the shore. So they've been sampling that foam, which shows the PFAS in the foam on the beach can be 80,000 times higher in concentration than the PFAS in the water that came from the factory. Because foam is the most efficient way to concentrate any type of chemical out of water. And the reason why PFAS is taken up by an air-water interface of a rising swarming group of air bubbles is because it's a soap. It's a surfactant. And soaps get uptaken onto a gas liquid interface. So with, like in this industry, like that line is really important, and there's a couple of technologies that have been like pointed out to be the winners in the future to manage our space. But they cost a lot of money. Liners cost a lot of money, and a multi-stage foam fractionation unit costs a lot of money. We always will come back to that question: who's paying?
You guys talk about short chain and long chain. Can someone just are they? Obviously, there's a difference from a compound. Is there any? Which is the most problematic, or they're just all bad?
They're all bad. In some
Okay,
sense. It's
just keep it. Let's keep it simple. They're all bad.
Yeah, it's all bad. It's
All
just-
bad,
Yeah,
'cause,
they have
like-
their hits is what it actually changes across the different compounds. So that's what they do. So like you imagine a little worm that has different crowns, and all they do is when you change a different crown, it's a different PFAS, but the body has the same component. So
It's
that's
all bad.
Yeah, it's all bad.
All right. Can you thank Charmaine? We're losing people. Oh, questions. Good. All right. Oh God, lots of questions. I'll start at the back and then I'll work forward because lady.
A question regarding the research behind the use of plants and their absorption and dilution. I know we use a lot of it through when our leachate comes through, going through the different ponds and utilising nature instead of bringing in all this new technology that we keep burying. So yeah, is there much when we're analysing the leachate coming through different types of plants and their ability to dilute the substance?
Are you talking about like natural vegetation plants?
Yeah.
Okay.
Yeah.
But this is a man-made substance, right?
Yes.
Yeah,
Yeah.
okay.
So last year I attended a big conference.
You go a lot of places. How is your carbon footprint?
My life has been PFAS for about 10 years already. So ACOM is a big international consultancy, and they have a leading expert working out of the United States. I forgot his last name, Dr. Barry, someone anyway. So he did some research using an Australian native grass, and he showed that PFAS could uptake. This grass could uptake PFAS. I think it was PFAS grown in a petri dish. And what he found was that although it took out PFAS out of the leachate in this petri dish experiment, he also found that on the underneath side of this other thing, PFOA emerged out of the stomata on the underneath side of the leaf, evaporated, or could become available to pollinators to spread the contamination. So although plants can uptake in a wetland like a biomimic treatment process, those plants would have to be in a contained environment, so you can't have evaporation or pollinators on a big scale
Spreading it.
spreading it. It's not a simple answer. And like all this is
I don't know. No
Yeah,
good.
no,
No.
that's
Let's just stop with no. The gentleman in front.
We've just been approved.
Oh, sorry, there was someone behind you. No, sorry. Mr. Black shirt and then Mr. Red and White shirt. Sorry, I should be more articulate. I'm moving forward.
That's name.
Is it? Oh, what? It's my party. It's now black.
So just all these processes are great. You've got PFAS, you're concentrating, but you've still got PFAS at the end of it. You haven't given me a solution. What do we do with this stuff? How do we destroy it? Incineration, that's great. That sounds like a process, but is there a major chemical that can break it down? Gone, done and dusted. What we need a process where we can actually kill this stuff, not keep running around the process and it keeps coming back to us again.
So the world's moving away from incineration.
No.
Yeah, no, it's a really no, we don't.
They're moving away from it. So there's a lot of companies are developing supercritical water oxidation, subcritical water oxidation, reduction of fluorinated electrons. So once, this is what the ITRC have decided to do, that you have to find a technology that strips the PFAS out of the water or the leachate to below criteria and concentrates it from dilute to super concentrate in one step. Then you send that concentrate to a destruction cell that defluorinates it and mineralizes it back to water and other innocuous chemicals.
Sounds very.
Timeframe for that sort of
So
process.
ACOM have a system running up in Queensland. There's several systems running all over the world now. For example, like our on-stage fractionation system has been running up at Oakey Defence Base out the back of Toowoomba for nearly 5 years. It's concentrated 250 million litres of water, probably into 500 litres of concentrate. That would take probably 2 days to put that through a destruction cell to destroy it. Whereas if you put 250 million litres through a destruction cell, it'd take probably 6 months and millions of dollars using a high energy system to destroy it. So this is what ITRC have decided. You must have separation, you must have concentration, and you must have destruction. Don't kick the can down the road and dig up contaminated soil or dump contaminated water in a landfill or send it to a recycling facility, because all you're doing is moving contamination from one entity to another.
But that's not enforceable, that regulation. It's not enforceable, and it sounds very energy intensive, yeah, and cost intensive. Mr. Red Whiteshirt, and then I'll go to Mr. Red.
We've just been approved from the EPA, New South Wales, to build a new landfills. We're actually out of tender right now. And at no point have we been, it hasn't been suggested by the EPA in regard to this. And it wasn't on my radar, it's probably on Sheridan and Carolina's radar. But I'm just wondering, is that because we'd be scared of the cost of having to install a system, so they're not even asking councils to do it? So it's not on their radar either.
No, I don't think that's fair. I don't think that's fair. I think a lot of the liners that are being used now are capable of withstanding, but I guess we don't have an answer to the leachate and the gas very clearly at this stage. But I think it's a good conversation to be having with the seller, and he's on at 350 in the Osprey room, about how we're going to do that. So our landfill working group is talking with New South Wales EPA about all these issues. Yeah, so very happy to get involved with that. I'm just going to keep moving because we are going to run into afternoon tea. Mr. Red, jump up.
I'll be quick. In 2014, we would have been talking about asbestos. At Waste 2024, we're talking about PFAS.
And we did plastics all the way through.
What are we talking about at 2030?
Well, and so great segue into Australian context, right? Like, what exactly right? It's no different to other hazardous substances that we keep allowing to go on the market. I reckon our next one is going to be the engineered stone, right? So again, we've managed to go, we're going to ban it because we're worried about the construction workers legitimately, but no one's talking about what happens when it comes out of the homes and into our yards and all the stuff in circulation. Like, how do we start thinking about placement on market, managing legacy, as well as removal from the system? And we can't keep putting the cost on us, right? Like, it's actually got to go on the producers and generators. I would love for us to have a system like France where they put the true life cycle cost on the shelf when you buy it, because this concept of just buying cheaper and making it someone else's problem is failed, right? Like, no one can think that this is okay. Michael?
There was just one more quick question about the outputs of the green bin you were saying contain PFAS. But that is that a green litter bin with vegetation only, or with food as
Both.
well and packaging? Or if it's vegetation only, where's...
We're finding PFAS in Go as well as FOGO.
So PFAS can be in pesticides, it can be in wetting agents. So anyone who's got a drought-tolerant garden and that's starting to die, put a wetting agent on it, that can have PFAS
we haven't established what's an unsafe level, right? And again, because we lose the conversation, like, you know, I was expecting Dan Andrews in his North Face jumper in January out there talking about asbestos in New South Wales. Like, seriously, did we have a crisis? No, we didn't, because asbestos is everywhere. But we lost the conversation with the community. And it's very hard now, I think, with PFAS as well as asbestos and others, for any politician, and I think that's why I know that's why we're in a mess in New South Wales with asbestos, because nobody wants to get up and say there's a safe level of asbestos. It's a complicated message to have. And I feel like we're kind of getting to that point with PFAS, right? It's very easy to go, all PFAS is bad, which it's not, because it's in our blood. But who's going to be the brave person who stands up and says, after things like Williamstown, we can have a tolerable limit? And that's kind of our challenge, right? But our challenge as a sector is like, well, if it is that bad and we can't receive it, even though we can't see it, why is it still being allowed to be consumed at Kmart and everywhere else? It's got to have consistent policy and a global, like a government-wide approach to this, right? Because it's very confusing for the public. I just put up there, so I'm deeply frustrated on PFAS, as well as many things, because after the South Australian example, when I was working with a landfill, which is an appropriate place to put this material. We didn't make it, but we take it. And so we had a fully lined, highly engineered site that could safely manage PFAS, because it's better there than circulating, let's be real. We started working really hard, writing letters to everyone about stop putting it on the shelves. And that was 2019-20. And so here we are, 2023. Next year, we're going to get what ICAMS went through 2 years ago, and then it had to go through a process of mutual recognition, as I understand it. And we're going to have an ICAMS register, and there's going to be 4 of the PFAS go on there next year with some other things. Now, if I'm Joe Blow Public going down to buy my microwave popcorn from IGA, which I do regularly, and Aldi, I do not know when it's on that register that I'm buying popcorn at 12,000 parts per billion, and I'm nowhere wiser, right? So my view very strongly with government, and I'm very vocal on this, is that it's completely inadequate because it doesn't help me as a consumer. If you're in the UK, if you're in Europe, or UK I think still does it, you have to comply with the classification, labelling and packaging regime, and also the REACH regime. So you have to tell people they're buying PFAS, right? We have to know so we can make informed decisions. So, I beseech you all to annoy government as much as I do to say, this is shit. We need to actually let consumers know they're purchasing this stuff and it is a problem, and it's no longer acceptable just to say, you can't make compost out of it in Queensland. We don't want it. We don't want it, right? But equally, I don't want to buy it. So we need to all get really strong on starting to look at what's happening overseas and really saying to government, this isn't good enough. You've got to be protecting our community from this product. And there is not a hope in Hades, back to Kerry's point. We're not going to hit a circular economy when we keep allowing asbestos. It was BPA, and we addressed BPA, right? Think back to it. We're all getting all a bit antsy about our baby bottles and BPA, and we banned it. We actually did a good job of that. Bromides, another issue. We can eliminate CFCs, right? We can actually take action on this stuff, and I just think it's wrong that we're not doing enough at the front of the chain to deal with it. But we're actually going to get, at some stage in the not too distant future, we're going to get the NEMP 3, which is, again, going to whack us. We are literally the mole that gets whacked, that's going to start putting levels of product output on their market that we make to. Yeah, we don't make it. We take it. But I can continue to put my microwave popcorn. I can put dental floss at 15 parts per billion. You can tell I read this, Jeff, all the time, in my mouth, right? But I can't make compost output at any more than 3 parts per billion. That's just ludicrousy. So join us in being cranky and raising with government that we need to fix this, not just for our sector, but for all our friends and family and everyone else. If it's dangerous, deal with it, people. Can you just please thank our 3 brilliant presenters? We did beautifully on time. I hope you found that useful. Please make sure that you come and talk to 3. Who's feeling alert? Who's feeling alarmed? blame David B. And please make sure you keep talking about this and other important topics if we really want to change the world. We're back at 3:30. You've choices between a seller and his landfill levy, local government procurement, planning, and then illustrating circular economy. So 4 sessions, 3:30. Listen for Fleetwood Mac. Thanks, guys.